Okay, before we assemble this, I found a small mistake in this part. It doesn't have a hole at the bottom for it to assemble with this. So let me just go here and open this and fix that mistake and save it before we start assembling. So obviously and we also need a bolt, a sort of a small bolt that will basically hold these parts together. But we just need to go at the bottom, sketch, and draw a circle that is, use the dimension 30 millimeters, and we will extrude cut this circle by 20 millimeters, I think. Say okay, this is what we need, and that's how it should look like, right? Let me save this, and from this I also need to show you this. I made this part. After that, we'll just start assembling. You need to make this. Let me just guide you on how that's done while I close this. Okay, let me just flash the sketch that you need to make to produce this. This is the sketch basically. So just take from the origin. This would be the origin. This point. From the origin, draw a vertical line of 13 millimeter, 2 millimeter sideways, 2 millimeter to the bottom. Then move in slightly, and then drop it down to this same level where you started, and then connect these two. Afterwards, simply give it the dimensions. So this is 13 millimeter, this is 2 millimeter, this is 2 millimeter, and this wall and this wall, use the smart dimension to give it the dimension of 1.5. These two walls are 1.5. Then go to the mirror entities command, mirror entities, here it is, and select this, and this. Obviously, basically all these features that you just created. And then in the window below that, it will say mirror about. So you need to mirror about this. You'll select that, and you'll be left with this surface, this shape, basically. This sort of half I, right? The letter I in the English alphabet. And then you will simply go to features and say revolve boss base command, this one. Let me just move out of that. Revolve boss base, and in the sketch you will revolve it about this line. So obviously it revolves in that direction and gives you this. So let me just start moving into the assembly process now that that's over with, and start assembling this individually. So the bolt is already here, because that's the first part that's the last part we made, so it'll appear here. Go to assembly, go to insert components. In this assembly, you'll say insert components, and it'll browse. In the browse, select all the components from this one to this one, except the bolt. The bolt has already been imported because that's the last thing you worked on. So now all those components will need to be placed individually and slightly farther away from each other, so that just zoom out in such a way that they don't collide with each other or cause problems for us later. We just carefully place them small amount of distance from each other so they don't cause problems for us later down the line. That there. Put this away from here, and put this here, and this is the last part. This is the base, and that is exactly what we are going to start with, basically. First, we will select the base. You can see it highlighted. You select that. Right click this and say fix. After that, we will move to this and we'll go to this command called mate. See that drop down menu? In the drop down menu, we will click here on the side of this small stub that's coming out of the base basically, and we will also click on the side of this hole. You'd see it's already starting to move things around. It says what kind of relationship you want these two to have. Because they're both circles, that stub and the hole, we said we need a concentric relationship. You see a circle within a circle, that means the centers of both these circles are at the same point, therefore they mesh perfectly. You'd say okay, this check mark next to it. You'd say okay. Now you can move this up and down, but it won't go anywhere. It will rotate, and that's exactly what we need. But it won't move anywhere else. It will move up and down, but only above this, because now we've given it a relationship with the bottom. So move that out of the way and zoom in. We'll click this. Now this face, the top face of this little stub, and the next part we need to select. Every part needs to have at least two relations to have them mesh together. And this inside face, you can see this inside face. Click that, and it's gonna ask obviously now again what type of relationship you want these two to have. These two faces, you would say coincident. This I'm hovering my mouse over it, it's saying coincident. That's already been selected. It's say okay, now this is connected. You can see it's connected. It'll rotate about this. It won't move up or down. It'll just rotate about this. Now we will connect this this part to this part. So we will do the same with this. Click on the shaft and click on the inside surface, because that's the two things that will be making contact. Making sure that the mate command is obviously turned on in this case scenario. And then again, it's asking what kind of relationship you want these to have. If you pay attention, this little menu, it says concentric. Both the circles are in line with each other. Let's say okay, and then we select this face, and then select this face. Now, obviously, it's we need to flip direction, so we flip direction. So now that this direction is flipped, and again it's asking coincident. I flip direction using this button, and the relation is coincident. So we'd say okay, this is what we need, and we can rotate it out of there. Now you can see it's not going to go anywhere. It's going to stay in there because it needs to be concentric with the hole that was in there, and it needs to be those two, the end of the hole and the face of the stub needs to be in contact with each other, which is what we specified. So it won't go anywhere. It will obviously clip itself through, but we can limit that in the rotation afterwards. But right now, that's not our priority. The next part is going to be this. Again, same thing. Click on the wall of the hole that needs to be meshed, and then click on the wall of the surface. Again, asking what relation, we say concentric, and then afterwards we simply select the face that will mesh with each other and move it outwards slightly so I can look into this face as well. There you go. And again, it's a coincident, that's already been selected in there. We don't need to do anything. Now there you go. It's this part is selected, and you can individually move these. Now that move these. These are constrained with each other, so it'll move similar to what it will move like in the factory in real life. Obviously, it will flip through each other, but like I said, we can limit the rotation of each of these parts. Once you mate one thing, the mate command is still on, so you can just start doing the next surface, unless you want to perform some other operation or import one part by one. Obviously, this is a simpler geometry or simpler machine, but if I recently made a turbine that took a lot of put a lot of strain on my PC, so you can just import it one by one and not put too much strain on your PC. But anyway, the same thing goes for this. We will click on this surface and then click on the wall of this hole because that's where it's going to connect. And we say concentric and we say okay. Now that obviously that part is stuck in there, we will move it out like this and then select this face, select that face, and it's mating, but it's not mating in the direction with it. So with that flip mate alignment, there you go, it's flipped, and the relationship it developed in that is coincident. So we'll say yes, this is what we need up to this part. So you can see now this can rotate, this can move up and down, this can do this, this can obviously, all individual parts are free to move and do what they should in their own specific degrees of freedom, basically. Okay, moving on to this part. We will do the exact same procedure. It's very basic, it's very simple. Obviously, click on the wall of this, the wall of this, and it will align itself again. The same relationship, it's saying concentric, say okay, we need this, and then we'll move it out, move it away, because right now it's only constrained in one dimension. Move it outwards, and you might be able to spot a mistake here that we didn't create two of these stubs. Instead, we just created one. But we did create two holes, so this obviously in reality we'll have two of these, but never mind. The same thing, we've constrained it with this, basically this hole, right? So we will click on the face of this hole and then the face of this, and it will join. We'll say flip it, it's flipped, okay, and the relationship is coincident. Okay, and now you can see that this is, let me just rotate it so it's not colliding with the other parts. Problem is it's pulling away all the other parts. Now that there's so many, let me just stretch it to the maximum so it stops starts rotating. There you go. Only three more parts left. We're gonna have to import one more job, but obviously it's gonna be just a copy of itself, so won't be much of a problem in that department. This is the next part. You can drag these individually and move them closer for ease of installation. Click the walls inside. Click the walls of this stub. Relationship is as usual. Relationship is concentric. Click the face of this. Move it away. Click the face of this, and relationship is coincident. Obviously, those faces need to be touching each other, meaning that this part is not going anywhere. It will be rotating, but not going itself anywhere. So you can see it's rotating. The entire assembly is starting to come together very nicely. And the final obviously is the jaw that we will use this bolt passing through here to hold onto these two holes, this hole and this hole. So let me just do that. Let me also go to assembly and import another one of those front arms basically that we made, and that would be the last part. So 7 would be the one that we made. There it is. We'll place it close to the face of this, was that's where we need to assemble it. And let me just move that here as well. Let me move these closer to get these in place for the assembly. So let's go, let's finish this off. We need to make sure that this go to mate command. In the mate command, this face is already selected, so we simply just select this face and it aligns it. It needs to be coincident, but right now we also need to now specify that inside of this circle and the inside of this circle needs to be concentric, and we need to flip these. There you go. Make sure that the teeth are inside. Yes, teeth are inside, definitely. And the relation is concentric. Say okay. There you go. The let me just fix this for a second so it stops moving, and let me, so the operation is right, it's doing its proper operation. Same thing for the other one. We say this face and we mesh it with this face. Just there you go. And then afterwards we say this relation obviously is coincident. If it still stays in the transparent, meaning you haven't specified the relation, and we specify this needs to be concentric, we flip it and it says okay. And here we have I made that mistake. I made that exact mistake. I think, let me just control Z this and I think the mistake is made because the face of this face needs to be coincident with this face, not that one. So let me just go back one more, control Z, so it undoes that last mate command. Let me select this face and select this face and say that these need to be coincident. It might give us an error. Did I add this mate and break the other mates to satisfy it? Yes. It went crazy a little bit, but that's exactly what we needed. And then in this, now that this is coincident, we just need this and this to be centric. There you go. Okay. Now the teeth are at the middle, and both the jaws are obviously in the place. We do need to still insert the bolt that we made, the last part basically. Remember that little arrow that appeared in when we mated this surface to this one? That error is still persisting, and it's saying it's over defined, this part, if you see it at the bottom here, at the bottom right. And if you look at the mating trees, there's also showing an error, and this is the error, that I've specified this face to be coincident with this face as well as that face. You can see that in this, that's saying it's coincident right now with this face, but you said it needs to be coincident with this face, which is an error, which is a paradox. So we simply go ahead and delete that relationship And there you go, the error is removed and everything is back to normal, all the relationships satisfy. It doesn't say over uh, basically over defined or any constraint, so this file will not have a problem if you sort of import it into some other software like ANSYS for analysis or simulation, stress analysis, or anything else. I'm glad it didn't break the PC or break the assembly when we made that sort of joint. So this is rotating, this is rotating. I think they've fixed this part. So yeah, the rest of it is fixed, which is why it's not moving. But I will make it movable once I've put that last bolt into its socket, into its place. Not letting me move it. Oh, I haven't clicked the move command. Anyway, let me import one more of those bolts. So bolt, port, and I will place it here nearby. And in the assembly, there is the component, move component. I don't know how I was able to move all those components individually without ever encountering a problem, because it usually doesn't allow you to move components if they are just floating in thin air like they were. But if you ever encounter a problem, you can do this. You can just click here, move component, and then move them individually wherever you want them to be. Anyway, we want the shaft of this to be concentric with this. Sorry, I haven't turned on the mate command. The mate command is on. This face is already selected. This face, specify the relation, say this, and then we select this face of this bracket and rotate the camera. Let me zoom out so it doesn't rotate so aggressively. Rotate the camera so that we can see the face of the stud or the bolt that will be basically making contact with that face that we so wanted. Zoom in, this face. There we go. It says what type of relations they coincident, and now you can see the stud or the bolt has been inserted in there. I think the length might be incorrect because it didn't come out the other way. It should have been longer, the bolt, the stud basically. It was actually 26 millimeters, and in this case it's not protruding from this side. It should sit on top of this, and I think the same will happen to this one. Click on the shaft using the mating command and click here. Click the same way we did before. These two surfaces, and it needs to be concentric. Why move that entire thing? Control Z. I think that bolt is fixed or something, which is why it's not moving, because I was using the move command and it wasn't moving for me. What if I just delete it? Let me do this and then try once more. If it doesn't work, I think I might have pressed some wrong buttons or something. I think that's that bolt is glitched or something. So let me go out of the mate command and select one of the bolts that I've imported, this one, and delete it for now at least. Yes. We'll just simply import another one. Import this. Click here. Go to mate command as before. Select the shaft. Select the wall that it's going to be making contact with. Concentric. Yes, that's what we want. And then the face. First, select the face of the bolt that's Usually the harder thing to do. And then select this face. There you go. And like I said, I think the nuts or the through bolts are not long enough, but still specify the relationship as coincident, and there you go. The bolt is definitely sticking out from this side, but not that side. I think all we have to do in this case scenario is go to the bolt, open the tree of the bolt, and in the this tree there is the sketch that we did for this. We'd say edit sketch. It'll tell you to basically uh, save this. So let me just save this assembly in that same folder where I have everything else saved, and it already named it assembly, so I don't need to change that. So save all component documents must be saved, so save all. And let me, it's good that it's showing me like this, so I can just edit and increase the length in a way that it'll cause the, it's very nice that this entire assembly turned into the wire preview, so I can just easily um, make it normal. Again, I can easily see through and perform the operation I need to perform. In this case, this is the value that needs to change. We'll make it 14 and see if this works for us. Problem is it increases the length on both sides. I think 14 might just be the um might just be the value that we need in this case, or it might not be the value, considering the distance from this face to this face might just differ because all this entire assembly is sort of tilted and twisting in its place. So let me see if I can correct this. The bolt definitely moved out and then it applied that relationship. I think I need to do that once more, but slightly move it again. Go to edit sketch. Let me go and increase it by another 1 millimeter, which will make it 15 millimeters. Now, why didn't it change? For some reason it didn't change. There you go. I think it should be 15.5 because let me just make sure. Go and yes. Then it comes out on the other side. So I think 15 was the right value. It should have been 30. But the rest is done. If you, the rest is done. There's, I don't think, any more relationships to be maintained in this 15. I'm just doing minor aesthetic changes. This is not sort of not that necessary or professional. There you go. It's restored. We move out of the sketching phase, and you can carry that procedure out for the other bolt because also it's not sticking out from the other side. But right now you can see they're both flush with the surface. And if we were to unfix these, I think I had these fixed. Let me just allow them to, one of these is fixed. I'm not sure which one. Look, there you go. Once we do that and make this part, I don't know why this part is appearing as a wireframe. There you go. In this, now we can rotate the individual parts. You can see we can't move this part because obviously we had that fixed, as this is going to be fixed. But everything else is rotating, moving up and down. You can see this rotates. think a few more parts might still be locked, but still, we understand what this is, how this works. Thank you for watching. This is the end of this series for the assembling and designing of a robotic arm.